So there are a lot of problems in computer science and physics that are pretty confusing, like the halting problem, for example. And I've found that AI can actually explain this stuff pretty nicely. So in this video, we're going to have AI explain the halting problem in simple terms to us. So it says the halting problem is a famous problem in computer science that asks, can we write a program that can always tell if any given program will eventually stop running or loop forever? So it's like, can we write some code that will take in other code and tell us if it's going to stop eventually or if it's going to run forever? And it says, why is it a problem? Well, imagine if you have a magic program called halt that takes two inputs. It takes a program P and an input I for that program. Now, halt of P and I would tell you, yes, if program P eventually stops when given input I, or no, if program P runs forever when given input I. So yes is like it halts. Halt is like another way to say stop, right? So if I put in a program and this says halt, if this says yes, that means it stops. Otherwise, if it says no, that means it runs forever. So Alan Turing proved that such a program cannot exist. We cannot write a program that does this, which is a pretty interesting thing to prove. And I always wondered, how could you prove something like that? Well, we're going to see in just a minute. So that means it's impossible to write a program that can correctly predict this for all possible cases. And here's the paradox that proves it. So suppose that we do create halt. Then let's create a new program, paradox, that uses halt to check if a program stops. If halt says, yes, it does stop, then paradox goes into an infinite loop. If halt says, no, it runs forever, then paradox stops. So paradox basically does the opposite of what halt says. So if halt says it stops, paradox says, no, it goes on forever. And if halt says it goes forever, paradox says, no, actually it stops. So then we ask halt, what happens when it analyzes paradox running on itself? Okay. Now I'm going to ask the AI to clarify this because this is what always confused me in the past. So it says if halt says paradox stops, then paradox actually loops forever. And if halt says paradox loops forever, then paradox actually stops. Now my brain is a little bit steaming right now. This is just like a bunch of words to me at this point. It doesn't really make that much sense, but we're going to see some actual code in a second. So then this says this contradiction proves that halt cannot exist. And it says, why does it matter? It tells us some problems are undecidable, meaning no algorithm can solve them for all cases. This has deep implications for AI and software verification. We can't always predict whether the program will crash or hang. Mathematics. Some truths can never be proven by an algorithm. Computability theory. There are limits to what computers can do no matter how powerful they are. In short, some questions are just impossible for computers to answer. And I'm like, okay, cool, but I'm a little lost on this contradiction here. What is being fed into what, right? Ask halt what happens when it analyzes paradox running on itself. Paradox. So is paradox an input to paradox? That was the confusing part for me. So I said, please tell me the actual inputs and outputs and why it's a paradox. Okay, so it says assume halt exists, and it takes a program and an input for the program, and it tells us yes if it stops and no if it runs forever. Now here's the program that breaks halt. Here is paradox right here. So paradox is it's a function, and it says if paradox itself, so here's the self-reference, if paradox halts, right, if this is yes, then this returns an infinite loop. It just goes on forever, right? And if this says no, it does not halt, right? If this returns no, which means paradox loops forever, then this just stops the program immediately. It just returns 0 and stops. So this says it calls halt on paradox and none to check if it will halt. If halt says yes, meaning paradox would halt, then paradox enters an infinite loop. If halt says no, meaning paradox would loop forever, then paradox stops immediately. So this is the self-reference, and this is what proves that this cannot exist. This halt function cannot exist. Because of this self-reference, if this says this stops, it actually goes on forever, right? And this is the function right here, paradox. It will go on forever. And if it says it goes on forever, it will come down here and it will stop immediately. So here, this is the contradiction. Case 1, halt says yes, so paradox halts. By definition, paradox should stop, but paradox sees this result and enters an infinite loop. It was supposed to halt, but it doesn't. Or halt says no, paradox loops forever. By definition, paradox should run forever. But paradox sees this result. I mean, paradox sees it, or I would say halt sees a result, and then it halts immediately. And that's a contradiction. It was supposed to loop forever, but it doesn't. Since neither answer can be correct, our assumption that halt exists must be false. So why is this a paradox? We assumed halt could correctly determine whether any program stops, but when we feed paradox into halt, its behavior contradicts halt's own prediction, no matter what halt says. This proves that no such program can exist. Some programs are simply undecidable. Yeah, so I mean, ultimately we would feed in paradox into, we would feed this function into halt again, right? And it would check it and it would be like, oh, you know, it's gonna stop, and then, oh shoot, it goes on forever actually, or oh, it's gonna go on forever. Oh no, it stopped right away. So I think this finally cleared it up for me. You know, it may take a little bit more careful thinking. I hope this is correct. I'm just a lowly human trusting AI to not completely make this stuff up to me. But I think this is a helpful explanation here to see it written in code. So I'm going to do a few more of these AI explains videos because I think they're pretty useful. So yeah, thanks for watching. Don't forget to like, subscribe, and I'll see you in the next one. Bye.